So thank you all for being here, and a very good afternoon to everyone. Before we introduce ourselves, can I see a raise of hands? Have you encountered the name called SQL injection, or are you prone to these kind of attacks? Okay, right. I see a lot of raised hands, which means that I no need to focus more on SQL injection, and in fact, our session is not about the SQL injection. So there are other modern attacks beyond SQL injection where the attackers or the hackers have moved on. So we will not be touching more on the SQL injection parts, but the latest modern PostgreSQL threats which we might be identifying. We have encountered few of the things which we have identified with most of our customers, and we try to present it here. Before we start with the content, let me introduce myself. I am Kranthi Burada, and I'm a senior database migration specialist. Been with AWS for close to 8 years, currently based in London, and I help the customers to transition from their commercial database engines to open source like PostgreSQL. So this is where I help the customers to understand the advancements, what we have got in open source, and get rid of the licensing costs which it encounters with SQL Server and Oracle. And I'm also an AWS certification SME. If you are anyone who is interested in AWS and are planning to go with the certification, you might encounter some of the items or questions which I might have written or reviewed. And with that, let me hand over to Narendra to introduce himself.
Yeah, am I audible, guys? Yeah. So thank you, Kranthi. Myself, Narendra Tawar. I'm a senior database solution architect based out of Amsterdam, working with Dutch branch of AWS there. It's been over 2 decades that I'm working with the databases, name it Oracle, Postgres, MySQL, SQL Server. My encounter with the Postgres was almost a decade before. What a coincidence that I started learning Postgres from this city, and today I'm presenting something about the Postgres within the same city. Back in 2015, I came here for 2 weeks extensive professional training when I used to work in Pune. I call myself always a student because I'm very obsessed with one of our leadership principle which we have at Amazon. We call it learn and be curious. So I always keep my curiosity on and keep learning new things. I'm pretty sure you will also learn something new when you get out of this room, and you'll pass it on to the community, build the community, and so on and so forth. So having said that, I'll hand it over to Kranthi again, and I'll chime in after some time.
Thank you, Narendra. It's always good to be back, right? So talking about the things we will be discussing today is we have identified few of the attacks which has been prone to the cybersecurity things. And the first thing is privilege escalations by extensions. PostgreSQL is far more advanced in the open source community, and we've been leveraged to use extensions left, right, center. And we will be identifying if there are any vulnerabilities or misconfigurations could lead that to a cybersecurity threat. So we'll be having some case study scenarios, and we'll be talking about that. And the other thing is timing and side channel attacks. So this is one of the favorites for attackers or hackers to get hold of your applications or the databases. We'll be talking briefly about those. And logical replications, how it can be abused. So we being the migration specialists, we generally recommend the customers to go with the native logical replication method when they're transitioning from data center to AWS, or even from other cloud providers to AWS, right? So we have encountered that by still using these legitimate features of PostgreSQL, there could be a threat. And we will be identifying if there is any misconfigurations done on these logical replications, what could be the threats which could totally compromise your application. And the next one would be role inheritance pitfalls. So right from understanding any of the scenario or any of the feature, we start with the security, the identity and access management. We start with understanding what is the best way to give the least privilege. So we kind of know already how the role inheritance works, but we want to again touch upon how the role inheritance pitfalls could look like, what are all the latest issues we have dealt or we have witnessed in the open community, where lack of role inheritance could lead into a larger cyber attacks. So, and finally, we try to keep everything into a a capsule to understand what could be the key takeaways from this session. So what can we take it forward and implement to our organizations or for our workloads. So with that, let me start with the privilege escalations via extensions. Before starting and diving deep into the issues, let us understand the feature intent, right? So gone are the days where we used to use the PostgreSQL just as a data store or a regular database, right? So now we are living in the AI era, and God knows what happens afterwards. So what happens is we are living in an era where we are using PostgreSQL, which is one of the most powerful open source engine. And thanks to the community providers who are integrating that with extensions. So there are a lot of extensions which could add as an add-on for existing database. So me being an advanced developer who want to learn more about AI, I could go with an extension called PG Vector or PGAI as an extension and see how my existing application can be a AI-driven one, right? So the extensions is just not about AI. We are seeing timescale DB. We are seeing HStore. If you want to integrate that with foreign data wrappers, trying to integrate with Oracle, MySQL, or even PostgreSQL to PostgreSQL, we leverage these extensions so that we are making PostgreSQL much more powerful engine, right? So with this comes with a greater responsibility. If you don't configure it well, there could be some chances that it could be prone to a cybersecurity threat. So what could be the common misconfiguration patterns? We see that allowing non-super users to create the extension. Me being the enthusiastic developer in your office space, I want to learn more about how an existing PostgreSQL could be an AI-driven one, right? Me as a developer doesn't have super user, but if I still can create an extension on top of it, try to do testing, see how good it is, and coming on the next day to the office, I feel like my CTO would be giving me an appreciation, but that will not be the case, right? There are other extensions. There are many more allow list extensions which could be unverified, which I felt like PG vector could be, or any other vector or any other extension which is onto the AI space. I feel that this is convenient to work around, but that might not be the case every time. So allowing the non-super users, if anyone can create an extensions and play around with it, maybe it will be a good for upcoming days, but that is not a performance optimized manner. And existing extensions as well. If you feel that every extension is safe, then that is wrong. So even with the legitimate features of using the extensions, for example, logical replication, for example, foreign data wrapper, and we'll also be seeing one scenario where the extension could be of legitimate use, but it could be abused. So understanding how the extensions will be used is also a critical one, and not trying to treat every extension as a safe is one of the primary protocol to make sure that your applications are safe. Let us talk about the case study. This is something which has happened in November 2025, which is quite latest one. I have added a hyperlink as well. The details will be available in official PostgreSQL documentation. It comes with CVE to 2026. So this happened with an extension called PostgreSQL Anonymizer. So to give a brief about it, the PostgreSQL Anonymizer, as the name suggests, it tries to create the data masking. So for example, if you are dealing with very sensitive data, PIA data, healthcare related stuff, or credit card information in your prod environment, you got millions of users who are dealing with credit card information or very critical or sensitive data. And as per the audit requirements, you need to migrate your prod data to non-prod environments. But again, as per the compliance requirement, it has to be data masked, right? It has to be anonymized. So that is where we leverage one of the best practices. We also recommend to the customers to use this extension, which is called PostgreSQL Anonymizer. So what happens here is, let us say the attacker or the abuser here can have an access to create, he has got create permissions to create functions or procedures or some packages in public schema. So that could be our scenario, right? They don't have access to any of your data, but he can have an access to create something in public schema. But what happens with PostgreSQL anonymizer is the objects or the features which it can be created, it will be created without having the schema prefixes, which means that you need to create the search path upfront so that you can leverage the values or the anonymity of the values which you are trying to bring in from the prod environment. So at that matter, the escalation can happen. Here is the abuse path. The attacker creates a malicious custom operator, which means that since he has got access to the public schema, he creates some malicious activity like a procedure which could inject inject some malicious activity to expose your metadata, or it can expose your sensitive data. So the escalation part, how it looks like is when you try to create the extension by a super user. You feel that since I am creating a extension, I am a super user, and no one has got access to this, you feel that it is all secure. But what happens is if you don't give a search path, it automatically runs any procedures or any objects which are related to exact requirement what you are supposed to do it in the schema, in the public schema first. So what happens is the abuser or the hacker will be just created the store proc, and he is just waiting for the moment to happen. When you create this extension, then that's it. The ballistic radius of issue is that you have incorporated the malicious activity into your database. It could compromise your database. It could access your metadata, or it could also even access your sensitive data. You feel that you might have created row level security, but that will not help us. So this is the standard case scenario. We didn't make this up. This is something which has happened in November. So all the details will be available in here. And this is one of the scenarios where extension, something which has been created by super user, and this is an eligible extension which we feel that things will be okay. But a slight misconfiguration could expose your complete data, or it can compromise your complete application.
So just a quick add on it, how does it work? Like, the attacker, they have created this functions or operator exactly mimicking the same name in public schema that extension use underneath. If you look at the code underneath, it has some non-schema prefix code where it uses those operators. So the moment, let's say DBA for any anonymization process, let's say they want to refresh data from production to lower environment, you have SSN or a username, email, whatever it is. To do that, they use this extension, and because this particular extension doesn't use the schema prefix, when the DB executed that, it went to the public schema and it ran that the malicious code which compromised that Postgres server, and the data was already exposed before it is being anonymized and PI, before handing over to the SIT or performance testing or a developer for that matter. So this is a recent one. Yeah, over to you, Kranthi.
Thank you, Narendra. So how can we have a defense strategy when it comes to extensions? The first thing is enforce strict extensions per allow list. So there are a lot of open source extensions which are available, and since it is open to everyone, but we need to make sure that based on your requirement or the business value requirement, do we really require foreign data wrapper? Or if that is not the case, you can remove that in the allow list. We feel that foreign data wrapper or any other extensions, we feel that this could be a common extension which should be available with PostgreSQL. But if it doesn't serve your business case, then you need to remove that extension in the allow list, which means that if me being an enthusiastic developer want to create a foreign data wrapper, it doesn't allow me to create. So the first thing is the enforcing strict extension allow list. And as we discussed earlier, restrict who can create extensions. It should always be the super user who has to have control on creating and maintaining the extensions. If any of the DBAs other than the super users or any enthusiastic developer who wants to create, I want to create a timescale database application, I want to have this, I already have the data, let me make it much more evident, I need to improve the existing workloads. If that is not part of your If he is not part of your super user, then that could lead to calamities afterwards. And I cannot stress more on this monitoring and auditing. It's always have an alerting system whenever you create a new extension. Even your extension is part of your allow list, make sure that you have an alerting system and monitoring. And of course, auditing, maybe I've seen customers who do this auditing for every quarter, and I've seen customers who do this auditing every 3 quarters. So always make sure that you have this auditing in place upfront for the extensions. So even though there is extensions in the allow list, if they are not used, you can change from the allow or deny list accordingly. So the second one, this is one of the famous methods which the attackers or the abusers leverage. It is closely related to the SQL injections as well. So we try to put everything, since it is more or less uses each other. So timing and side channel attacks. So talking about, before talking about timing attacks, let us briefly talk about the performance optimization. We are all so obsessed with performance optimization that we want every query to be quick. Even the Blinkit, we want it in 10 minutes, right? So we are moving in a fast paced way, and we are sometimes not thinking about what the vulnerabilities it can bring into the table, right? So the thing is, we create heavily optimized, PostgreSQL is heavily optimized for performance. We feel that these features reduces the latency, and the security assumptions what everyone thinks is the DBA would be having a different opinion, but the developer could be having a different opinion. For example, the developer wants this query to be executed within 10 seconds. But having a right security protocol, it might take, it might go into a separate index, or it might be going in another security phenomenon, and it might take 20 seconds. But DBA would want to ensure it, but developer would try to ignore this. So that is where the code configuration and the code writing is also has to be very important when it comes to performance optimization. You need to have a balance upfront, whether you are compromising on security or are you compromising on the performance, or you evenly balancing both. So that is the third criteria, has to be very particular when you are dealing with any critical data. So how the misconfigurations could look like. So me being the developer, I want the query to be quickly executed, which means that I'm providing a hard-coded sensitive information like the password. Right, the password hard-coded like admin123. The password is password123. I just hard-coded so that the retrieval speed is much faster, right? So when these kind of conditional joins or filters, when you provide the sensitive information within it to get your data retrieved much faster, then you are kind of exposing that information or giving that as a feed to the attackers or abusers to play around. So let us talk about the pattern, right? How you might be seeing that I want this to be performantly optimized, but how can that be a attack path? So the scenario here is, let us say the attacker or the abuser or the hacker doesn't have access to your sensitive information. We'll go with an example like healthcare, or maybe the financial firm where it stores all the credit card information, or the healthcare which holds the records of the blood reports, like a particular user has got an O positive or an AB positive, which means that the only thing which the attacker need to know is the column name of the blood type, right? The blood type could be, the column name could be just like blood type, or it could be alphanumeric, right? So in that, what happens is the abuse path, what the attackers would use is going with the binary search logic. When it comes to the healthcare information, like the blood group, he can be leveraging the Boolean conditions, or he can be leveraging the individual characters. So he can start with O. If the retrieval speed is much faster, then the attacker could second guess that this particular blood type of this user could be O. This is not just for the sensitive data, it is even for the sensitive information like the password. So the length of the secret, we might have been, even if you are using Apple or any other phone, you might be giving a alphanumeric password, which is quite rigid, which is as a best practices, we are all recommended to use alphanumeric with higher strength of password, right? If you are going with the password of password 123, which means that it can be easily prone to compromise. So what this abuse path would look like here is the attacker would start with going with a scenario where he goes with the substring, having the password, and for the username admin. So most of the admins or most of the scenarios, or even in Aurora PostgreSQL or RDS PostgreSQL, what we have seen is they are going with the common username as admin or admin123. So the abusers will be trying their luck with going with this username, and the prompt, if you have seen that we are removing lately, but I've seen in some startups back in London, they are giving the prompt like username is right, password is incorrect. So that information itself, which means that the admin is the username, and they will be creating a loop to identify what could be your password. So they will be using a function called PGSleep for 5 seconds, and if the first letter is A, then they will be identifying the pattern. How long would it take? Is it taking 5 seconds to retrieve the data? And if it is exactly matching, then they can second guess that the first letter of your password is A. So it will be in a loop format, and what the abusers would do is like they will be creating a continuous loops, and it will be reiterated, and try to abuse. Since the attacker has got the read access, he will be start injecting the select statements throughout your application, and though they don't have access, they will be looking at the patterns on how fast the data is getting retrieved, and based on that, they will be identifying what is your credit card number, what could be your blood type, or what could be your password. So this is where your application can get compromised. Though they don't have readily available the data, you're just giving your passwords to the abusers. Right. So what could be the defensive strategy for this? So to start with, for any conditional logic, try not to give your hard-coded secrets. Go with the parameterized way. And there is a concept called prepare statements for your PostgreSQL. So if you find a pattern, let us say that a common query pattern, what we see with financial services is they might be retrieving the data based on the card details or account number. So that particular query has been regressively used by millions of users. So going with the prepare statements, you are feeding that prepare statement already for that pattern, and what it does is like it will be parsing that information already into the query optimizer. So in a way that this is good for security, in performance optimization, so no need to reinvent the wheel every time, and also making sure that it will be restricting the abusers to do the SQL injection accordingly. And always detection is a primary before trying to see why it got exposed and the troubleshooting afterwards. But it is always important to detect any abnormal query patterns you see. For example, if you say that your application is Amazon.com, right? And you might be observing a pattern, seeing that the password has been clicked 100 times within 10 seconds or 200 times within 20 seconds. So this is the pattern what the SQL injection users do. So behind the scenes, what these attackers does is they just don't type manually. So they create the bots, they create the loops, and they try to inject every time when according to the loop. So identify this abnormal behavior or the timing patterns. Right? So when this particular query, though it is an incorrect statement, if it is been hitting 100 times, 200 times, then that should be your caution to identify that your application is prone to a SQL injection attack. So always make sure that the monitoring is in place to detect these kind of anomalies. Another case study, this is something which is observed in Jan 26, which is quite new in one of the scenarios, this side channel attacks. This is famously called as visible statistics leak. So what this does is, to understand the scenario, the PostgreSQL, it plans the efficient queries based on the patterns what we have seen, right? So it will be doing all the data distribution in the metadata called PG statistic. So if you keep on using a same query on and on and on, it will be having that PG statistic. It will be identifying what type of indexes are used. Is it using a sequential scan or is it using the right type of index? And it lets the query optimizer give the best plan possible. And how the abuse path could look like is, let us say, for example, we are going with the very sensitive data. Again, we are going with a credit card information. You have created row level security for that particular column. You feel that it is already secure, and even the abuser or the hacker tries to do a select star from where credit card equal to, you will not get the data, which means that they don't have the data or they don't have access to your data readily available, but they can have access to see the PG statistic information. So previously, I also mentioned about having access to the metadata is also equally vulnerable if you are dealing with these SQL injection attacks or some cyber security attacks. So what here happens is, he will be looking at the PG statistic and he will be identifying the most common values column. What could it be? So it could be a social security number, it could be your phone number, or it could be your credit card number, or any of the sensitive or PIA data. These are kind of very critical information. We don't want the databases to be compromised on. So this is where the mitigation, what we have seen in this scenario is, this scenario has happened with the lower versions of PostgreSQL, and with the latest versions, it has been identified that even to run your PG statistic, they need to pass the RLS checks. So in a way, what we are trying to explain here is, you need to run your applications. If you're dealing with any of the sensitive data, you need to make sure that you're running it in the latest versions of PostgreSQL. If you are still going or running with version 14 or 15, make sure to check on this link, and your application might be prone to some SQL attacks. I'm not saying that that will be possible, but if any hacker is planning to target, this could be your vulnerabilities which you need to take care of upfront. And with that, let me hand it over to Narendra. We have seen logical replication as one of the features of PostgreSQL, but even there, even if it is a legitimate feature, there are some abusing can happen on this logical replication. So over to you, Narendra, and explain what
Thank you. Thank you, Kranthi, and thank you for a wonderful insight so far. So logical replication, I think it is a common, me being a Postgres database solution architect at Amazon, we enable customers to adapt onto the RDS Postgres or Aurora, right, for that matter. And one of the common migration pattern that we use is use the pgdump, pgrestore, and use the logical replication to do the CDC or ongoing changes replication till the cutover. Or it could be a pub/sub model that you create to build centralized data lake or the warehouse system or a database where you can subscribe from the multiple publisher and have those in place. One of the other crucial use cases, like when you want to do the major version upgrade. So it's commonly seen that customer across the globe use logical replications to migrate to upgrade the major version upgradation with their database systems. So this is the commonly used use cases, and we often think that this is something can easily be configured. There is nothing to worry about. But there are some misconfiguration patterns that one need to review before going into the proper replication and understanding the possibilities of getting it abused, right? So common use case, you create one replication user, or maybe you use the super user to create the extensions, the replication slots or the pub/sub and everything, right? For a replication also, you use that only, and you use across all the environment. So one DBA once creates one replication user, and that has been used for all across the environment with the same credential kind of a thing. So again, insecure network configuration, when it deals with the PGHB config, when you have some allow list for the replication user and all these things, that's where the potential challenge that you could see. Again, as I mentioned, the common mistakes that one can do is data movement is non-sensitive. No, it is very sensitive, because maybe you are thinking that I'm just restoring some tables, set of tables, subset of tables, or some tables in the schema or group of schemas. It's still normal because I'm not exposing all my data to the target subscriber system, right? So let's talk about this. This has happened last year, I believe. Yeah, it was last year, where again a common method that we use, me as a DBA, traditional DBA, like we use the PG dump to take a backup and restore onto the target. So even if you don't, if you are not transferring the data, usually what you do is you transfer the metadata, so you have your all tables, procedure, and stuff like that available. So what has happened with this specific attacking pattern or a use case, right? There, let's say you take a PG dump backup of a metadata only, a schema only, without data, right? So the attacker were having some privileges on your primary publisher. What they did is they inject the malicious metadata within the PG dump file, backup file, that unknowingly, let's say DBA or admin or operator that taking a PG dump backup, right? Name it data or metadata for that matter, took that backup, restore that metadata onto the target, right? The target replication server, Postgres server, or a subscriber for that matter. With that restore, it invoked the malicious command, that metadata which was having some packages. It invoked the malware, and it installed the malware onto that particular replication instance or a server for that matter. And assume that it is a subscriber for a multiple publisher. Whereas when I was talking about the data lake, right, or a data warehouse system, where you can subscribe the data from several publishers. So now the attacker has got full host access to that particular subscriber whole node, and they can run any OS command. So in a way, that subscriber is compromised, and it can be get more dangerous when it exposed to the additional ecosystem of other publishers, right? So again, what it result is, I remember even me being advising to one of my customer, I asked not to. I mean, many cloud providers, they have locked down the logical restoration path to their ecosystem until unless this security patches get updated, right? So again, the mitigation part, when it comes to the mitigation part, it is always use the binary format instead of the over the plain text, right? So it is always advisable to use the binary format, a dump file, where it cannot be plain text, no one can be inject any malicious metadata, and always run on to the latest patch version. Yeah, before going to the before going to the defensive strategy, one of another aspect that I have come across, one of my customer faced this. One can read your replication data slots data out of your PubSub model. So a group of hackers, they created a Python script using the PG output plugin. They were able to read the replication slot data before the replication data, the slot data can read by their actual PubSub model. In that way, they have get into their replication slots and read those data and made sure that, and logical replication, how does it happen? It transfers the data, right? It's a logical. If you are creating something, inserting something, all the values they get exposed, right? So that is one of the use case, and again, it's depend on intent, what damage or what kind of an intention a hacker group having, right? So one of the use case that I have seen, there are some extension, unauthorized extension, that somebody created onto the development environment or some non-production environment. And then through that, they got access to the production system. And somebody created a replication slot and stopped consuming it. Having said that, if you don't consume the replication slot, your wall files get increased, all those space and everything, and you have potential server crash or a production system down in this case. Again, as I said, what is the intention? If the attacker groups want to damage you with your customer presence and penalties and to breach the SLAs and RPOs and RTOs. So this was one of the use case. So let's talk about some defensive strategies. Again, as Kranthi mentioned, enforce the least privilege mechanism in place, right? Use only replication user, use specific dedicated user for a replication for a specific PubSub model or PubSub group, right? Don't mix it all across the different PubSub models, right? PubSub mechanism and environments across. Again, a replication role is also important in this case. Make sure you always have monitoring in place. For example, the life cycle of your replication slot. How I am able to, is there any replication slot which is causing more time, right? Is there a replication slot which is consuming more data and are not getting released? Are there any unused replication slots? Because this is a common mechanism that we use for a replication. Any replication tool, like for AWS we have DMS, that underneath use the test decoding or a logical extension to do the CDC changes, right? So all this kind of a slot life cycle and activity must be in place to spot any new replication slot created. As I mentioned that somebody creates a replication slots and leave it. It can crash your production system, right? So make sure that you have all this level of mechanism in place and make sure all this ecosystem is visible, what's happening where, you get proactive alerting and all these things. The last model is also the crucial one, the role inheritance pitfall. This is commonly seen as a feature where I have a big organization in place where I have many developers, DBAs, operators, backup operators, testers, system integrators, performance testers. In that case, you create multiple roles, right? And by creating roles and delegating some privileges, set of privileges, group of privileges, or a set of roles for that matter, it makes your life easy when you deal at scale, right? It simplify your access, and the role inheritance is something like that. It can automatically combine your, let's say you have primary user, right? Role A, there is a row chaining, role A, B, C. In that case, your main role access can get inherited to a third level or a fourth level for that matter. Again, roles are mainly designed to reflect trust the boundaries. We think that the roles that we have designed and granted, it trusts the boundaries for a security, but it's not always the case. Quick misconfiguration patterns. Again, as I mentioned about the role chaining, I have a role A, then I grant it to role B, role C, role D. In that way, you get lost, right? So default inheritance is always enabled by default in the Postgres. So make sure that you disable that, right? So this is one of the pattern. And this third point is one of very crucial point that we or DBAs or security folks assume that roles are designed around the job titles and not the threat models. Make sure you define the roles on the threat model rather than the job titles. So this is something which is very interesting. So let's talk about one of the any quick hand. Like, can I have a raise of hand? Have you heard about the crypto mining attack last year? Quick raise of hand. Yeah, we have quite a few. Yeah. So what happened last year? There was an attack where 1,500 odd PostgreSQL servers host got compromised, abused to do the crypto mining. And how they did it, it was once of its kind, out of a box. What they did is, they scan a common pitfall with the user and access management, right? The common username, password, the weak username, password, Postgres servers running onto the the common port 5432, right? With that, they were able to get into the system. They created a decoy user which looks like a system user, PGCQL_sys. That means nobody can monitor that user, what is happening. Actually, maybe something is happening with that user. It is the user which looks like a system user, right? Then on top of it, they use very powerful program called copy for program, right? It's a Postgres feature, very powerful feature, which is used to run a shell command without running onto the KSH or onto the shell file onto the system. With that, they ran everything in the memory, so that no antivirus can go to the disk and scan that malware. Everything was happening in memory with pgmem, right? They killed the competition. They deleted all the prior compromised servers attacks malware so that nobody can come in. They created, this is one of interesting point, they created a process for that malware resemblance same as postmaster. So even if during the crypto mining, a DB or operator see that if my process is taking 100%, you think it's a postmaster process, right? It's nothing to worry about. It's my own process. So in that case, you have this kind of a mechanism, and they use this for a CPU utilization, all these things, right? So quickly on the defensive strategy part, and then I'll hand it over to Dwarka to Kranthi for a closure. Make sure that you do the explicit role switching. Don't do the role chaining, A to B, B to C. Always set a role. Continuous audit is always required. Make sure that you don't use the privileges elevation. This is very key. Copy from program must be disabled if it is not being used for any specific reason. And again, make sure that you disable the role inheritance, which is set by default. Having said that, I'll give it to Kranthi for a quick takeaways so that we can move to the next session.
Right. So in the interest of time, the key takeaways is something you have already discussed. Always make sure that you have the monitoring and everything in place. And I just want to conclude with one-liner, like the punch. Like the punch code of or the core messaging is that if a feature can move data, or if a feature can execute logic or combines privileges, it should be part of your threat model. So any feature, we are currently sitting in the evolution of PostgreSQL, and version 19 comes in, and God knows what else will be added on to the already existing PostgreSQL. So if any feature you want to try it out, it has to be part of your threat model, and make sure that it is secure enough to have your applications running without any worrying about these SQL injection or hackers. So with that, I would like to thank you. And yeah, we can connect offline as well. And thank you all for giving the opportunity for us. And you can connect over LinkedIn with us, and we'll be more than happy to have a communication or contact with you and exchange ideas accordingly. Awesome. Thank you.
Thank you so much. Keep learning, guys.